Hello there, welcome to day 2 archived video from Twitch. Now you might be asking yourself, why is this video different from others, especially day 1? Well, first of all, day 1 video I will count as a test stream, as A, the quality was not as good, and B, there was not as much commentary until the very last few minutes where I worked on the game object class. Second, it seems that there was some encoding issues from Twitch, so I cannot upload directly to YouTube. The encoding problems were probably due to my background music. As such, afterwards, this day 2 video, I will stop using background music. And I guess we're all learning, and so note to self, don't play background music if you want to archive to YouTube. Alright, so what I'm going to do is I'm going to give a brief rundown of what happened on day 2 of the project, and then finish the video, post-edit it, and then upload it onto YouTube for those who are following along purely from YouTube instead of looking at the live stream itself. Alright, so we worked on our texture manager and the manager class. Now in libgdx, or just any game library in the world, there is usually a class that manages resources, i.e. Textures, sound, any class that contains the data in which you're trying to load is what I call the resource class. And above that, there's usually a container class. And what a container class does, is that it has a reference to a resource class, and it pulls information from that resource class and allows it to be used with the library. Example in libgdx being sprites or music. Sprites has a reference to texture, and the sprite contains information relative to the screen where that texture should be outputted. So what I'm trying to do is I'm trying to create a manager, a system where I'm able to manage the available texture so that I don't load the same texture twice. So what ends up happening is libgdx, just the texture class itself, it does not care about how many instances of texture it has. In fact, you could load the same texture 100 times and it will do that into your memory, and that is not very good for our system, especially if we're trying to design for Android, because Android doesn't have much RAM. Well, most Androids anyways. That being said, if you're familiar with libgdx, you might realize this sounds very familiar. In fact, it is. libgdx has its own version of this system, and that system is called, let's see if I could find it, Asset Manager. And what Asset Manager is it's essentially what I talked about, but it's in a very general sense. So Asset Manager is a manager for all the managers, such that you're able to pass in, well, libgdx, they call it a loader. You pass in a loader and it's able to manage that specific class. So you give it a texture loader, and every time you give a file location that is a texture to the Asset Manager, it will make sure that that texture is unique. Now, the reason why I'm not doing it, not using Asset Manager, is for two reasons. Number one, it is because I'm doing this project in a way so that others can learn of sort of what happens if you're in charge of more of these type of classes where we have all the gimmicky stuff, the texture, the container classes done for us, but we haven't actually worked on the more engine-specific asset managers and input, etc., etc. The other is because I have my own custom C++ sort of manager-like system that I usually use for games that I learned some time ago, and I've been using it ever since. So during the live stream, if you see and catch it on Twitch, you will find that I have C++ open from a previous, actually from a game that I'm currently working on the side, that I try to port to Java. So that is the current situation where I'm porting my own custom texture manager in so that our game could utilize as well as the viewer can learn from this experience. Another thing that I noticed when I checked the asset manager code is that it is very massive. In fact, I would say if you're just a person that is working with libgdx, you could totally work with just asset manager itself, as it is very well written. It is designed for what it's supposed to do. It is 10 times larger than the code that I have. And it gets the job done for any type of game that is possible on the market. That being said, I'm still going to use my texture manager as well. I'm trying to learn from this experience as well. One more forewarning is that I am not as skilled in Java as I am in C++. That means sometimes I need to search up references as I tend to forget them, such as what is the iterator initialization for Java. I do not recall, and so I have to check that out online. In C++, it's quite simple. You could use the auto keyword and then get the iterator, or just get the begin of the map, hash, whatever. Alright, now let me give a kind of a brief rundown of the two classes that I created during that live stream. First class was the manager class. So the manager class is the base class for trying to create any manager. So what I'm doing is, since there's so many resource classes in libgdx, I create a template so that it's able to accept any type of resource class such that it's able to manage it. So if you look at this class, you will see that there is a resource name, file name, and the object passed into the constructor. And what that does is that is what we call the default resource. So what I want to do is say, if a manager deletes an object, we want to make sure that that texture information is replaced with a default resource. And what happens is later on we'll have something called a handler. Now a handler essentially is very similar to a manager, but it manages the containers. And so if a texture gets deleted, that handler will make sure whatever sprite or music that is associated with that texture will get replaced with the default resource, or in fact it would just refresh refresh this texture to get the same location in linked hash map, but now it's pointed to the default resource. Now that might sound very confusing. If so, don't worry, we'll do that on day 3, where we will write the sprite handler and the handler classes. So since this is a base class and we want to be able to extend it, we have 3 abstract functions just for managers. We have the load resource, unload resource, and update resource. Now if you look at libgdx's version, they have very similar functions. They also have load and unload functions somewhere in here. Here it is, load async, load sync, and other stuff. And so what these function does is they're kind of the functions that you call if you want to load that particular resource. Quite easy to understand, and we'll look more in detail for texture manager, but essentially load resource, once it loads for that particular resource, it will return a object that just has been created or added so that it's convenient for the user. There's also a unload resource, which is basically a way for us to get rid of that resource during, let's say, changing scenes in our games, or just changing a new state in our game. Now this is used because we don't know whether or not we need to do something with that particular resource file. For example, texture, you could just simply unload it, but with audio, you might want to pause that audio first before you unload that resource. Update is very similar to load, but what it does is update resource is called if that resource name has already existed and we instead just want to update that resource, then update resource will be called instead of load resource, or else load resource will not return a valid object. Now these are essentially helper functions. Resource exists does exactly what it says. It will check whether or not that resource exists within the class. Before I go on, I forgot to mention we have a custom resource class, and that essentially is sort of like a class that holds information for that particular resource. So we have a resource class with name, file name, and t resource, that being the object of the actual resource. Let's see here. Nothing that I need to mention. It is protected because we want to make sure that whoever extends this class will be able to utilize it. That being said, however, any class that is outside the manager class should not use resource and instead use the functions that are available to them. That is why we have the resource exists and get error resource. Now get error resource is just a getter for the default resource that we need to pass in for whatever class is extending manager. And it is a way to make sure that if anything happens, we don't throw an exception, but instead just throw a error texture. If you ever played any Source Steam games, then you might see the infamous purple texture or just any error models. That's essentially what this does. Next is the add resource. What add resource does is it essentially allows any classes that extend manager to add their specific resource, because what we're doing is we're making the linked hash map that has all the references to any loaded resource is private, so that no one has direct access except for manager class. So we're using methods. So we have add resource, remove resource, and get resource. Notice add resource requires the full resource class, while remove and get resource only needs the name of that resource. And one thing to note is that when we have a load resource, we only load the name of the file and the unique ID for that file and the name of that file. We do not attempt to throw in a custom resource object, because that we want to make sure that whoever looks at it does not see this class, as that it become confusing for the user. And then one more thing is the linked hash map has a string and resource. That string is the name of the resource, the unique ID. So you might be asking, why does resource have a unique ID that's stored in called name, and why is it that linked hash map also has a string called name? That is because even though it might sound redundant, that is used so that we're able to match up a hash map with a resource without relying on a vector, because we could theoretically use a vector and try to iterate through the entire thing to find the resource that we want inside the resource name, but that sounds very painworthy. Instead, we're going to use a linked hash map with a string, so we could use the built-in find function in order to find whatever we need to get. Alright, that is pretty much the manager class. Next, we have the texture manager. Texture manager is the class that extends the manager. It have two static final strings. We have the default resource name and a default file name. This is used whenever we pass in an invalid file name. And so we'll use this, we'll pass it into our constructor, or we'll pass it into our constructor, which calls the supers constructor, which will basically set our default resource. That being said, we created two types of constructors. One's our default constructor that pass in the default static values. The other is the normal constructor, where if we were to reuse this code, we're able to pass in custom default textures. So a default texture must be loaded in for this class to work. For libgdx, if we do not, this class will throw an exception. The load gdx files.internal. And this is just the the class that libgdx uses, the file handle, and it essentially allows us to load any file through any project because libgdx supports multiple distributions. And since we're working on Android only, our name of our file should just be the file name itself and no direct, absolute paths. And also for desktop, however, that would not be the same. But luckily, we're only just creating Android. But we're still using the internal function such that if there's any change to libgdx, it would depend on this function and should therefore change with the GDX as GDX changes. Alright, next we have load resource, which is essentially the abstract class defined in Manager, and we have a way where we check whether or not that resource exists. If it does, then we return that resource that we have using the get resource, and get resource goes to the map, and the map will then return a resource which contains an object of our actual resource, in this case the texture. And so it will return the texture, and that would be it. Now the other thing is the second line, which checks whether or not the file path given to this function exists. If it does not exist, then we return the arrow resource. If it does exist, then we add the actual resource into our map. Next we have unload resource. Unload resource essentially first gets the resource and the texture object, and it disposes it. What libgdx has is it has a custom dispose function, pretty much acting as a deconstructor in C++. That is because Java does not have deconstruct. The lifetime of any object in Java is unknown. So we have to custom call a function to kind of delete the loaded resource into our system. That is how libgdx works, and it's libgdx specific. So this texture manager is only specific to libgdx classes. And once we dispose of that texture, we then remove the resource class entirely stored inside our hash map, linked hash. It's pretty relative to the load and update resources. Update resource essentially almost the same as the load resource, except the fact that here I made a note during the live stream, if the given file name does not work, we will assign the texture to an error texture. Now this is unique because what I end up probably will be using this function for is if we just want to kind of update that texture and then immediately delete the case that I want to make sure that that texture disappears, the old texture disappears, and that the new texture is taking its place for sure, because I'm pretty much going to call this function in mind that I want to unload or delete the previous old texture. Alright, that is pretty much it for the texture manager. As for how we use the actual project, what we do is we create a texture manager, we call the load resource, and it'll return a texture, so we store it into this image, and then once we do, it should work, and it will give us a texture class that is handled. And here I have an update resource to test that function within the live stream. So that is pretty much it. I realized there are a couple things I need to fix, and I'll do that on day 3. Hope to see you then. I will basically on day 3 work on Sprite Handler, as well as any further test this class for any information that I might have missed, such as forgetting to dispose the resource if that file given is incorrect. So I need to dispose the resource here. Alright, again, I understand that there's an asset manager, and I recommend using that if you do not want to, if you're using your own projects that you're doing and you don't want to create your own manager class. Alright, that about wraps it up for today. Again, this is actually a recording specific to YouTube because I could not manage to export the Twitch live stream for day 2. hopefully that will be fixed for day 3 and above. And let's see if we could finish this project in 4 weeks to 5 weeks. Alright, thank you for watching, and I'll see you next time.